Hello friend, I, Dr. Sushila Sonare, Associate Professor in the CSE Department, SRITE. Today I am going to teach you a very simple and important topic, that is a linked list. In this video, I am going to cover following informations like overview of data structure, types of data structure, in that linear data structure, and inside of the linear data structure I am going to teach you linked list. And also in this video we will discuss about the array and what are the difference between the linked list and arrays. Okay, so first, when you want to write any program or any things, you have to know what is the input is there. When we providing any input, that input has to be processed and give the desired output. Okay, so that input has to perform any task. This procedure itself is called the algorithm. So data structure is a logical representations of data that will perform if some operation, that operation give the effective result, fast informations like this. Simple example is there. If you want to search any particular name in your file or record, you have to find out one by one informations if it is not arranged in proper manner. Or you can go for the another example like a telephone directory. If you want to search any particular person, you want to go the alphabetical order and then we want go to search the desired outcomes. Okay, so here data is organized. Some organization is there so that we can retrieve data easily. Okay, for similar way, in a programming manner or in a soft copy, when we want to store data, we have to organize into proper manner or some organize in a specific way so we can receive that data effectively. These data structures are divided into two parts, linear or non-linear. In a linear data structures, elements elements are stored in particular order, or something we can say the linear way. In linear data structures, we having the array, stack, queue, linked list, and so on. Linear data structures mostly a sequential way to store the data. Like an example, if you want to store data into array, you are taking or reserving the memory in initial stage, and this memory are the continuous manner. Then base address is showing the starting point of that particular array, and after that how much data size is there, that is the block size, and move one by one block to next block, or you can say the one space to another space, right? So through moving the one block to a next block, here in array we are using the index. Similarly, here is the informations. You can start the initial position and tracking to our data into the linear way. We having the one direction to pass the data and go to the particular scenario. That is a called simple way as a linear data structure. In a linear data structure, memory are mostly in a continuous way, or if continuous way is not there, we having the pointers to point to next location. So what is the linked list? Linked list is a small chunk of memory. In that we having the two field, data field or address field. Data field is taking or storing the proper actual data what you have to store in that particular node. Okay, so this node having the two parts, data and link. Data is actual memory, actual data, those you want to store, and link is denoting the pointer of that particular node type. That link is showing to the next location of the linked list. Initially, if you want to create a linked list, initially we are simply occupy the memory as a chunk, a small piece of the memory, and this memory is divided into the two parts, data and link. Data, actual memory we are going to store, and link we are making it as a null. That is the initially position. So this structure or node you can represent through the structure. Here a simple example is given. Structure node. That node is taking the value of the data. Might be suppose here we take the int type. So integer data and the pointer. This pointer has to point to the another node. So that data type should be a node type. Then we create a reference as a star node through node. Okay. And now why we are going to the linked list? We already have the array, and array is the very effective manner, very easy way to create the data into the organized manner. We previously occupy the memory in a continuous memory and storing data one by one. Through indexing, we can track the data. Then we having this type of simple way, why we are going to pointer and all. So here I am trying to list some problem. Like first point is resizing is expensive. How resizing expensive? Point is that, right? So you having the one array. Suppose A of 100, you are taking the memory size of 100 chunks, right? Continuous memory, and you are going to store the data into it. Suppose after some time you store data one by one, and only you fill up the data 20 to 25%. Remaining data is going to waste because this memory already you occupied, and until this program is executing, this memory is with you. You can't reuse that memory. Or another way, if you create a of 100 memory space, continuous memory space, and you started to store the data one by one, suppose you reach up to 99. Now 0 to 99, or maybe you can say 100 data already fill up. Now you want to insert another next data, but memory size is 100 only. So how can we store 101th data? For that you have to recreate the array. So you are reassigning or resizing that array. Suppose a of 100 increase by the 10 or 20. So you increase by suppose 20. So 120 size is increased, and you insert data. How you are going to insert? First you have to copy all data. 0th index values should be a 120 size array. In that you have to copy all of a of 100 data, and then only you can able to put the next data 101th location. So unnecessary copies is required. That's why we are saying resizing is expensive. But for the linked list, it is a very easy. When you want, you can occupy the memory chunk as a node. In that node, keep the data and point this node to the linked list. That means we can say connect this node to the existing linked list. That's it. Our task is over. Next is data insertion and deletions requires the number of shifting. Suppose we are making as an array ascending order. We are creating a data into array in an ascending form. So data is arranged already. Now suppose you insert the data 2, 4, 6, 8 and 10. Now data 5 is coming. It has to be put it in between the 4 or 6. So before, how you are going to keep this 5 into that particular place? You have to shift 10 or 8 one left direction, make the space free, and keep this 5 into the free space. Then only you can able to put the data into that particular location. So shifting is required at that condition. Similarly, if you are going to delete and you have to make the continuous way and try to removing the free space middle of array, you have to again shift it, right? But in a linked list, uh, data insertion and deletion of any point is very easy. You can insert data into the first position, last position, or middle. Very easy. Only updating the pointer's value and your task is over. In an array, random access is efficient by using the indexing. Only through the index you can track the array. But in the linked list, you have to track the linked list by the pointer, that is the start pointer or head pointer somewhere. Is it written as a head pointer or maybe a start pointer? So that start pointer has to be a travel starting position to up to end position, or you can keep the one pointer p and move it. So that random access is not available in a linked list. You have to track one by one step. In an array, memory wastage is more because you occupy some array and it is a very large array size, but you didn't use it. That means that occupied memory is not going to use anywhere. It is a waste memory. So you can't able to access that data. But for the linked list, when you want, you can allocate assign the memory allocation to particular node and connected this node to existing linked list. It's very simple. In an array, we having the sequential access through indexing one by one, increase by the indexing value by one, and you are able to read data fully continuous memory, right? So it is a very fast. But for the linked list, no sequential access is allowed. So sequential access is not there. That means our access rate is low because memory is allocated in the different places, or maybe can say the randomly allocated memory. So you have to travel through the pointer by one pointer to next pointer. So it is a little bit time consuming. Thank you for watching this video. We will go for the next video, some operation like linked list operation, insertion and deletion, and how it is working. So keep watching. Thank you for that.